The sun rises every morning. It feels constant, reliable, unchanging. The light reaches Earth, warms the surface, and quietly powers almost everything around us. Plants grow because of it. Weather systems depend on it. Even the air you breathe is shaped by it. But imagine noticing something unusual. The sunlight feels slightly weaker, not dramatically, just a little less each day. At first, nothing seems wrong. But over time, temperatures begin to drop. Winters grow longer. And slowly, the balance that supports life begins to shift. This idea is explored in the film Project Hail Mary, where scientists discovered that the sun is losing energy due to a mysterious cause. But this raises a deeper question. Could something like this actually happen? To answer that question, we need to understand something fundamental. What does it actually mean for the sun to lose energy? Every second, the sun releases an enormous amount of energy into space. This energy travels as sunlight, the light and heat we experience every day. Even though the sun feels constant, it is not static. It is continuously producing and radiating energy. So in a sense, the sun is always losing energy. But that loss is part of a stable process. The real question is not whether the sun loses energy. It is whether that process can suddenly change. To understand this, we need a simple mental model. Imagine the sun as a massive, self-sustaining engine. At its core, something extraordinary is happening. Hydrogen atoms are being fused together to form helium. This process is called nuclear fusion. When these atoms combine, a small amount of mass is converted into energy. That energy slowly moves outward and eventually leaves the sun as light. This is what powers the sun. That energy does not leave the sun immediately. After it is produced in the core, it begins a very slow journey outward. Inside the sun, energy moves through dense layers of hot plasma. It is absorbed and re-emitted again and again, changing direction constantly. This process is extremely slow. The energy produced in the core must pass through multiple layers before it finally escapes as sunlight. By the time it reaches the surface, it has transformed into the light we see. So when you feel sunlight on your skin, that energy may have begun its journey deep inside the sun long before it reached Earth. But here is something important. This process is not random. It is balanced. Gravity is constantly pulling the sun inward. At the same time, fusion is pushing energy outward. These two forces balance each other. This balance keeps the sun stable. If fusion slows slightly, gravity compresses the core, increasing temperature and restarting fusion. If fusion speeds up, the sun expands slightly, reducing the reaction rate. This self-regulating system prevents sudden changes. Only a tiny fraction of the sun's energy reaches Earth. But that small fraction is enough to power almost everything on this planet. It drives weather patterns, ocean currents, and the growth of plants. Even the food we eat and the air we breathe are indirectly connected to sunlight. Earth's temperature depends on a balance. Energy arrives from the sun, and Earth radiates energy back into space. When this balance remains stable, the climate remains stable. Even small changes in incoming solar energy would gradually shift that balance. So what about the idea in Project Hail Mary? In the story, a fictional microorganism called astrophage absorbs energy from stars, causing them to dim. This is an imaginative concept. But in reality, there is no known mechanism that can suddenly extract energy from a star in this way. Stars are not passive sources of energy. They are active systems governed by powerful physical laws. This idea reveals something interesting about how we think about stability. From our perspective, change often feels sudden. But in astrophysics, most processes happen over enormous timescales. If the sun's energy output were to decrease, the effects would not be immediate. The change would unfold gradually. Temperatures on Earth would begin to drop over time. Weather systems would slowly adjust. Seasons would shift in subtle ways. This would not feel like a sudden event. It would feel like a slow drift. But here is the important part. In reality, the sun does not change in this way. Its energy output is remarkably stable. Small variations do occur, but they are extremely minor and happen over long periods of time. The kind of rapid energy loss imagined in stories would require a mechanism that does not exist in known physics. The sun will not remain the same forever. Over billions of years, it will slowly change and eventually run out of fuel. But that process is gradual, not sudden, not within human timescales. Even small changes in solar energy would affect Earth. But those changes would unfold slowly, giving systems time to adjust. What feels like a dramatic shift in a story is, in reality, a very slow transformation. So what is really happening here? The sun is constantly producing and releasing energy through nuclear fusion. This process is balanced by gravity, creating a stable system. While the sun does lose energy continuously, it does so in a steady and predictable way. There is no known natural mechanism that would cause it to suddenly lose energy and dim rapidly. Stories like Project Hail Mary imagine such scenarios to explore possibilities. But in reality, the sun's behavior is governed by stable physical processes that operate over billions of years. The next time you feel sunlight on your skin, it may seem simple. But behind that warmth is a balanced system that has remained steady for billions of years, quietly powering life on Earth.